Hello everyone, welcome back. And in this video, we are going to see it in code how to do topic modeling using sentence transformers. So first let's connect our Google Drive and then load the embeddings as well as the movie plots. So if you have seen previously, I've already created this American movie plots 2005 to 21 embeddings.csv, which simply contains the full embeddings using sentence transformers. We can as well just calculate embeddings on the fly, but in order to make all the calculations fast as well as run this notebook experiment with it easily, I've pre-created the embeddings for each of the movie plot. Now let's install our main libraries. So sentence transformers, perhaps we don't need it, but we are just installing it because we have already created the embeddings. Now we have UMapLearn and HDBScan. These are the main libraries. So UMapLearn converts your high dimensional vector that is of 364 dimensions etc. into lower dimensional vector, whatever you want, let's say 5. Then HDBScan is the clustering algorithm that we are going to use. As mentioned previously, you can use k-means or HDBScan. HDBScan creates a unique cluster just to identify all the outliers into one. Now I've commented out some code. Essentially, if you don't have pre-created embeddings, you can just take the plots and run through the sentence transformer model to create all the embeddings on the fly. We have already done that previously, but here we have already created the embeddings, so just we are loading the embeddings into this embeddings underscore movies variable. Now here comes the important part, where we are taking these embeddings of all the movie plots, 3300 plus movie plots, and then we are using UMap to do dimensionality reduction. So we are doing two dimensionality reduction. One is for converting these points into 2-dimensional vector and one is for 5-dimensional vector. Why are we doing this? Simply we will use the 2-dimensional vector for visualization, whereas the 5-dimensional vector will be used for clustering. So we will convert the 364 dimensional vectors of all the movie plots, each of them into a 5-dimensional vector, and we can use HDBScan to do clustering on the 5-dimensional vectors that we have, and we can use the 2-dimensional vector just for visualization sake. That's why we are doing both these dimensionality reductions to 2 dimensions as well as 5 dimensions using UMap algorithm. This will take a little bit of time to run, but we have already seen what are these UMap components. You can go ahead and look them up. Basically the neighborhood to consider as well as the minimum distance and metric that we use. Okay, now we are done with that. Let's come to this section where we are using HDBScan. So we are taking the 5-dimensional embeddings of all the 3300 and movie plots, and we are doing clustering using HDBScan algorithm. So min cluster size is, in order to consider something as cluster, how many points should it include at minimum? That's what this is. And automatically you will also create a cluster for all the outliers that are there. Let's run this. Cool, we got 8 clusters, and these are the cluster labels. -1 represents the cluster label for all the outliers, so you can ignore all of them and you can only do topic modeling on these clusters that we have. So basically every time you run, you might get a different number of clusters and other things because of the way UMap algorithm works as well as the HDBScan. So you can change these hyperparameters and play around with them to see what's the perfect hyperparameter for the documents that you have, the size that you have, etc. So you can definitely look at all the hyperparameters of both UMAP and HDB scan and explore them. Let's run this. So the thing that we can see is that among 3,300 movie plots, almost 2,000 plus movie plots are in outlier cluster. So this is not very perfect. So perhaps the other thing that you can experiment with is changing HDB scan to k-means algorithm. Similarly, so when it comes to k-means, instead of using the lower dimensions, that is 5 dimensions, you can perhaps use the full dimensions, that is 364 dimensions directly without any UMAP compression, dimensionality reduction. So the short thing is that right now we are experimenting with HDB scan, and perhaps we do have some high number of outliers in this case. But if you don't want that, you can experiment with k-means algorithm to cluster the same way all the document vectors of our movie plots to give a fixed number of clusters, let's say 10 or 15 or 20, and try to use k-means as well. But here, for our simplicity, we are going to go ahead and see how the algorithm works more than fine-tuning the hyperparameters. Let's run this. So what we are doing here is simply we are appending the 5-dimensional vector as well as 2-dimensional vector and also the cluster label for each of the movie plots. So here -1 means outlier cluster and 2 means cluster 2. So we are just appending the data frame with all the labels as well as the UMAP reduced dimensions. Now, as I've mentioned previously, instead of using the whole plot, what you can do is just extract the verbs or adjectives from the plot and use them for cluster TF-IDF, as you have seen previously in the videos. Let's get all the plots in all plots variable and let's install Spacy. And what are we attempting to do here with Spacy? We are going to run each plot, each movie plot that we have through Spacy, and what Spacy does is extract a lot of things for each of the token. It extracts named entities and parts of speech, etc. And what I'm doing is removing all the proper nouns from that movie plot. As mentioned previously, we can remove all the proper nouns. For example, James and other names that we get, we can completely remove them and use only, let's say, adjectives or verbs or those combinations. So what we are doing here is removing the movie plots from their proper nouns, but you can do the other way as well, which I have commented here, which is just keep noun or verb or adjective however you want. Let's run this. Awesome. Now that we are done, let's move ahead. So whatever we just created, let's see that we are appending another column, filtered plot, that has the plots with their proper nouns removed. Let's see how it looks. So for example, you have this plot here, Jonathan Rivers is an architect and lives with. So Jonathan Rivers is removed because it is a proper noun, so it just says architect lives, wife, unexpected death, eventual. Because we are removing proper nouns, we are removing any punctuation or stop words even, so the stop words are removed. Again same here, Ken Carter lives in Richmond, Ken Carter is removed here. At the end of the day, you can modify this to remove proper nouns or just to keep nouns and verbs, or nouns, verbs, adjectives, depending on the use case that you are looking for. You can modify so that the filtered plot only contains the essential information. For example, if you are doing genre classification, perhaps nouns and adjectives, verbs are more important, and these proper names are not very important. That's why we are removing this. Anyways, now what we'll do is we'll do CTF-IDF. Now what we'll do is we'll do CTF-IDF, that is class TF-IDF on the filtered plot combination. So before actually proceeding with class TF-IDF, let's create a new data frame with just clusters and their corresponding text. Let's run this. So what do I mean by corresponding text is that, for example, cluster 0, if it contains 500 movies, then we are going to accumulate all the text of those 500 movie plots and just append it. So when I mean all the text, it is actually not the full plot appended, rather the filtered plot appended to each other. So we are going to collect all the cluster labels with 0, and let's say there are 500 filtered plots like this. We are going to append all those 500 filtered plots and create one large text that is present here. Similarly, we are going to do that for all the clusters. That's what you see here. -1 is outlier cluster, so we are going to probably ignore this. But the rest of the clusters, this is the appended text from all the movie plots that belong to this cluster. And we are going to do our class TF-IDF to extract keywords on each of these clusters. So this is the code for class TF-IDF. We have already done quite a lot of things on TF-IDF in the earlier section, so this code shouldn't be too complex to understand. At the end of the day, what's happening here is just we get the TF-IDF score for every word, for example, thunderstorm, traveling, circus, etc. So in order to get TF-IDF, we consider the frequency of this word within the filtered plot as well as how rare it is across other plots. And at the end of the day, to extract top n keywords, what you do is simply get the top n words from this filtered plot that have the highest TF-IDF scores. That's exactly what's happening here. So nothing too complex. So let's run these to see what we are going to extract. Let's just run this and it will be very clear for you. So simply put, what's happening here is we extracted the top 8 keywords belonging to each of the cluster. That's what we have done here. And we are appending another column which contains these appended top 8 keywords. That's what we are doing here, nothing too complex. But in order to actually visualize this, let's create this two-dimensional plot. And what this plot does is we are using the two-dimensional vectors that we have created, and based on which topic a particular movie belongs to, we are just going to mark them with that color and just cluster them. So in order to understand this well, let's kind of see this Masjid, Raisa, Adi, Ranveer, Dissident, although there are some names as well, because Spacey is not perfect and it can still extract some names, but we can kind of see this belongs to, let's say, Asian movies or something like that. Assume that this is Asian cluster. Let's look at this cluster in particular and see. So this is the orange cluster. So yeah, you can see that there is My Name is Khan, Slumdog Millionaire, Thalaiva, then few other movies, Hotel Mumbai. So you can see that it's kind of resembling Asian or Indian movies, right? So that's what we can identify from this cluster. Let's look at this cluster up front where this is okay. This is the big cluster right here. So the Chloe, Starling, Eva, The Good Woman, A Fall from Grace, Vampire Stuck, etc. So mostly it's kind of like you can assume spirituality or belonging to certain clique, etc., certain group. That's what this resembles. Then let's look at this cluster: surf socks, penguins, happy pet, VR bears, zoo. So you can kind of see that this cluster cuteness, etc., it's mostly related to animals. That's what you can see. So anyways, you can play around with k-means and other things, etc., but I'm just showing how you can do some kind of topic modeling automatically, where you can see that this is belonging to movies of animals, etc., and there is Indian movies and related, etc. So at the end of the day, what we can do is we can create some predefined genres. For example, comedy, Asian, animal, superhero, all these things, extraterrestrial, how many ever genres that you have, you can create that. And we can create a manual mapping to map from keywords to the genre that we want. For example, so here -1 is actually outlier cluster. So for -1, let's choose other, but let's roughly choose, for example, cuteness, crested, pairing. For 0, let's choose animals, and eaters, transactionist, herald, commoner. Let's just randomly choose some other names. For example, for 4, we can choose Asian. And similarly, I'm just choosing randomly, but you can fine tune to extract other keywords, just adjectives, verbs, or depending on the use case that we want. I'm just choosing some random ones for the other. And what happens is that once you choose the mapping, we can print them out. So essentially, we are converting all the keywords into a fixed genre. That's what we are doing here. So we are mapping each cluster to a fixed genre that we have. So it's kind of semi-manual. And like I mentioned, you can use some GPT-3 or large language model here to map this automatically. So the beauty is that once you run this, you will see that automatically we have mapped each movie plot to a genre, because each movie plot is kept into a fixed cluster, and from that fixed cluster we collected all the text data of that cluster, filtered that according to our liking, and extracted the top keywords, and from those top keywords we mapped it into a fixed genre. So what happens is that once you do this, the beauty is that automatically all the movie plots are assigned to a fixed genre. And similarly, you can do the same visualization, which is, instead of looking at keywords, for example, we have renamed this as animals. You can see the violet one here: zookeepers, penguins, surfs up, Pete's dragon. So this animals is what we have tagged. So essentially we have done topic modeling, which is automatically keeping all the movie plots into clusters, and we have defined a fixed topic for each of the clusters. So we kind of automatically extracted or created this column of genre without actually reading through all the movie plots. That's the beauty of topic modeling, which is identifying all the topics and assigning the topics. Now the beauty is that if a new movie plot comes, you can just collect the centroid of this violet cluster, centroid of this orange cluster, etc. And any new movie plot, you can see what is the closest cluster and assign the topic animals or Asian, etc. Or you can even do some soft clustering, where you can say that it belongs 50% to animals, 30% to Asian, and maybe 20% to superhero, etc. You can also do soft clustering. Anyways, this provides a base framework for you to try out. Of course, what we have not created is ideal, since we have quite a varied, diverse set of movies, as well as there's quite a lot to play with in terms of hyperparameters, as well as extracting the verbs or adjectives, etc. that we want. There's quite a lot that you can play with. You can replace HDB scan with k-means algorithm and see if you get better topics, etc. So I'll leave all that to your experimentation, but you have got a strong baseline on how you can do topic modeling, and then you can experiment with it for the documents that you have. Thanks for watching.